Welcome to the explainer that is literally going to fundamentally change how you look at the Cambridge 9709 mathematics paper. Look, whether you're building your foundation in syllabus codes like 0580 or 0606, working through 4024, 4037, or 4040, or pushing into the higher tiers of 9709 and 9231, the feeling is often exactly the same. You open that test booklet, and on the surface, the algebra looks like this totally chaotic, terrifying jumble of numbers and command words. It's intimidating, right? But I need you to listen to me carefully. There is no paper. There are only patterns. Today we're going to decode one of the most critical patterns of them all, the algebra binomial expansion for rational n. Let's be real for a second and look at two totally typical approaches to this exam that I see all the time. First, we have a student we'll call Alex. Alex is the kind of student who completely overloads their answers with raw mathematical facts but offers absolutely zero structured analysis to tie it together. Then we have Sam. Sam gets nervous, rushes through the paper in a total panic, and completely misses the specific command word requirements the examiner is begging for. When we look at their flawed answers side by side, literally covered in red pen marks, it is so painstakingly clear what went wrong. They are missing the fundamental underlying strategy. They're fighting against the exam instead of decoding the matrix behind it. Well, today, we are going to fix that.
Okay, let's dive right into this by revealing a massive statistic that should completely, and I mean completely, alter your entire revision strategy from this day forward. This single topic, the binomial expansion of 1 plus x to the power of n, specifically for a rational n, accounts for an incredible 15% of the total marks in Paper 2. I want you to really think about that number for a second. That is not just a tiny fraction of your grade. That is a massive, grade-defining chunk of your final score, and it's sitting right there in one specific, highly predictable area of the syllabus. Mastering this isn't just about casually memorizing a formula you might forget tomorrow. No, it's about securing a mathematical fortress that examiners repeatedly, consistently test year after year. If you walk into that exam hall without this code cracked, you're essentially leaving 15% of your grade completely up to chance.
So, here is our strategic roadmap for today to unlock the examiner's blueprint and secure those top marks. We're going to cover, number 1, the Paper 2 advantage. Number 2, core theoretical principles. Number 3, the procedural framework. Number 4, top examiner traps. And finally, number 5, evaluate and succeed.
Let's move straight into our first section, the Paper 2 advantage.
To truly understand how to get the ultimate advantage in Paper 2, we have to ask ourselves a pretty critical question. Why do students find evaluating evidence and actually drawing mathematical conclusions so incredibly hard? Before we answer that, I have a quick favor to ask. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so think back to our student from earlier, Alex. Alex actually knows the binomial expansion formula. If you ask Alex to recite it, no problem. But when the exam paper specifically asks to state the range of values for which the expansion is valid, Alex completely freezes up. Why? Because Alex has superficial knowledge, but totally lacks the analytical depth required to actually draw a meaningful conclusion. The difficulty here happens because so many students treat math as just a series of isolated robotic calculations rather than what it really is, a deeply connected logical argument. To conquer this, top-tier students use a variation of the Peel framework, but heavily tailored for mathematics. Check this out. P is for point. You instantly identify the correct underlying mathematical principle. E is for evidence. You extract the exact specific numerical values given in the question stem. The second E is execution. You show your step-by-step working flawlessly. And L is link. You tie your final numerical answer directly back to the specific context or command word they asked for. We absolutely need to shift your mindset from merely calculating a blind result to actually proving your deep understanding of the mathematical architecture using this exact framework.
Let's transition into Section 2, Core Theoretical Principles. Now, what's really, truly interesting about this slide is how perfectly it contrasts the failing strategy of rote calculation with the top-scoring A-star approach of deep, transferable analysis. Notice the stark contrast here. Superficial breadth is merely memorizing the basic formula, 1 plus nx plus n times n minus 1 over 2 factorial times x squared, and so on. Any student can memorize that.
Analytical depth, on the other hand, is knowing exactly why that formula only works when we factor out constants to intentionally create a 1+x format inside the brackets. It's deeply understanding how that rational power n, like a fraction or a negative number, completely, fundamentally changes the infinite nature of the sequence compared to a simple positive integer. The theoretical architecture of binomial expansions for a rational n rests on incredibly precise definitions. For instance, the absolutely crucial condition that the absolute value of x, the modulus, must be strictly less than 1 for the infinite series to actually converge and give you a valid approximation. The syllabus is super clear on this. It explicitly emphasizes that top-performing candidates exhibit this specific conceptual understanding, which allows them to transfer these principles to completely weird, unfamiliar contexts that the examiner throws at them to test their true grasp of the math.
So the absolutely crucial point here is understanding exactly how the Cambridge examiners assess you based on these core principles. The assessment objectives in the syllabus are broken down into 4 key areas: knowledge and understanding, application, analysis, and cross-topic connections. And here is a massive secret straight from the grading room. The principal examiner reports continually highlight that candidates who master cross-topic connections, for example, actively linking a binomial expansion to a complex partial fractions question, or using it for coordinate geometry curve approximations, those are the students who achieve significantly higher marks. This is exactly where the Peel framework we just talked about really shines. If I give you 30 seconds right now to look at a highly complex, multi-part question, the student who applies their knowledge to make a solid point, meticulously extracts data for evidence, uses flawless analysis for execution, and then perfectly links those cross-topic connections, well, that is the student who inevitably walks away with the A-star.
All right, let's move into Section 3, the procedural framework.
Let's be entirely honest for a second. All that theory we just discussed is completely, utterly useless if you cannot execute it under the extreme, ticking clock pressure of a timed exam. This is the exact moment we transform those red pen marks on Alex and Sam's disastrous papers into beautiful green check marks. Let's talk about the ultimate secret weapon, the method mark strategy. In Cambridge mathematics, the process is heavily weighted. Examiners award method marks, often denoted simply as M marks in the official mark scheme, for demonstrating clear procedural steps. They want to see your brain working. They emphasize that the process is just as important as the final answer. And honestly, sometimes it's more important, because even if your final numerical calculation is slightly off due to a calculator typo, you can still save your grade. Think about Sam. If Sam rushes in a panic and just scribbles down a final wrong answer with no working, Sam gets a big fat 0. But if Sam takes a breath, writes down the correct binomial formula, consciously substitutes the rational power n correctly, and clearly sets up those factorial denominators line by line, Sam secures the vast majority of the method marks regardless of a minor silly arithmetic slip at the very end. The method marks are your safety net. Use them.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, now that you're subscribed, check this out. This slide brilliantly illustrates the exact 5-step standardized sequence you need to process complex questions reliably every single time. Step 1. Identify key elements. Is it actually a rational power? Does the expression inside the bracket actually start with a 1? Step 2. Apply relevant principles. If it doesn't start with a 1, you must rearrange and factor the expression to strictly fit the 1+x to the power of n format. Step 3. Execute analysis with clear working. This is your Peel execution phase, writing out each individual term completely distinctly. Step 4. Verify results. Take a step back. Does the expansion logically follow the alternating sign pattern you'd expect from a negative power? Step 5. Present in appropriate format. Did the examiner command word ask for ascending powers of x specifically up to the x cubed term? If you give them x to the 4th, you're wasting time and potentially losing format marks. Let's do a quick 60-second mental data scan challenge together right now. Imagine a complex expression on your paper. Bracket 4 plus 2x, close bracket, all to the power of -1/2. Most students panic. Your brain should instantly trigger the code. I must factor out that 4 first to make it a 1. So you pull out the 4, but you remember it's raised to the -1/2 power too. 4 to the power of -1/2 is 1 over the square root of 4, which is 1/2. Now your constant outside is 1/2, and inside the bracket you have 1 plus 0.5x. Boom! That is what seeing the code looks like.
Let's transition into Section 4, Top Examiner Traps.
Okay, we've deeply analyzed the winning strategy. Now let's play a little game of Find the Flaw by looking at the top 3 absolutely brutal mistakes taken directly word for word from the principal examiner reports. We need to rapidly fire these off so you know exactly what bad habits to eliminate immediately. Trap number 1, using the wrong approach for the wrong context. Listen, this happens constantly when a stressed student tries to use the standard NCR calculator button or formula, which is strictly 100% only for positive integers on a rational fraction like -1/2. Doing that is an automatic 0. It breaks the math completely. Trap 2, forgetting to check format and presentation. The specific command word in the question says simplify your coefficients, but the student rushes and leaves them as big, messy, uncalculated fractions multiplied by factorials. You do that, and you just threw away your final accuracy marks. It's heartbreaking to see. Trap 3, answers not specific to the given context. The question explicitly asks for the validity of the expansion, and the student just lazily writes all real numbers instead of doing the actual work to explicitly calculate that the modulus of the specific substituted term is strictly less than 1. We have to ruthlessly eliminate these sloppy habits right now if you want that top grade.
The principal examiner reports delivered this ultimate examiner alert, a golden rule you should frankly have taped to your wall. Always define terms before using them in extended responses. In the specific context of the binomial expansion for a rational n, this means clearly, visibly stating your n value on the page. It means explicitly stating your substituted x term, and it means explicitly writing out the algebraic validity range before you begin blindly crunching numbers in your calculator. Doing this provides absolute, total clarity to the examiner that you fully understand the mathematical environment you are operating in. Imagine an invisible timer counting down from 30 seconds for you to speed write one perfect Peel paragraph defining your terms for a complex expansion. In that 30 seconds, you identify your n, you extract the correct x coefficient, you show the exact substitution, and you confidently state the condition for convergence. That level of meticulous precision? That is exactly how you secure top marks and leave the examiner with no choice but to award you the full points.
Let's move to our final crucial section, evaluate and succeed.
This right here is it. This is your ultimate mathematics success blueprint. It's a higher order, deconstruct, solve, evaluate methodology that literally pushes a candidate out of the average pile and straight into the highest possible scoring brackets. Let's walk through it. Step 1. Deconstruct given information. Pull apart every single command word like a detective. Step 2. Solve systematically. Deploy that Peel framework and the 5-step procedural method we just mastered. Step 3. Check for reasonableness. Look at your answer. Does a negative rational power yield an alternating sign sequence as you mathematically expect? If not, you messed up a negative sign somewhere. Go find it. Step 4. Evaluate alternatives. Ask yourself, is there a faster or smarter algebraic manipulation to simplify the brackets before I even start expanding? Step 5. Make justified recommendations. State crystal clearly why a certain numerical approximation is valid based entirely on the expansion's strict validity range. If you rigorously apply these overriding rules, command word decoding, Peel framework application, and this comprehensive time management and systematic evaluation matrix, your mark potential skyrockets from a failing percentage straight to 100%. Listen to me. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
So, as we wrap this up, the ultimate provocative question I have for you today is this. Are you ready to finally stop fighting the exam, stop guessing, and start actually decoding the code behind every single question? If you consistently apply this success blueprint in your very next past paper, I promise you, you will see your underlying understanding in your final grades completely and totally transform. The next time you face a highly complex binomial expansion, or honestly any daunting multi-part question on the Paper 2 syllabus, I want you to take a deep breath and remember our golden rule. There is no paper, there are only patterns. How will you decode your next exam? Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below right now with your specific target grade for mathematics and the absolute biggest challenge you're currently facing. Our team reads and responds to every single comment. Make sure to like and share this video with a study partner who needs to see this. Ace the Exams. Your Cambridge success starts here.